Now have a look at arc length. So let's think about how we calculate arc length in degrees. Use the circumference of a circle, which is pi times pi diameter, or 2 pi r. We'll keep it in terms of the radius, considering we're working in radians. And then we multiply that theta over 360, which is a fraction of the circle which we have. Now let's consider how we do that now for radians. So it's going to be the circumference of my circle, which is 2 pi r. Now let's think about what we are multiplying by here. It would be theta, but this time it would be out of 2 pi rather than 360 because we have 2 pi radians in a full term. So what you might be able to see here, if I write that all in fraction, it would be 2 pi r theta over 2 pi, meaning the 2 pi's cancel out on the top and bottom, meaning in radians, and radians only, our arc length is simply r theta. Let's have a go at the following question. So it says calculate the length of an arc for the arc of a sector with a radius of 6 and theta being pi over 3. So we know the arc length is just r theta, with theta being in radians. So it will be 6 times by 5 pi over 3. That will get us 10 pi, and that will be our arc length in centimetres. Question number 2. Calculate the radius of a sector if the arc length is 10, with theta being 64. So what we can do here is we can use our formula for the arc length being r theta. However, we are going to have to convert that 64 degrees into radians first. So if we do 64 times by pi over 180, just to convert that into radians, that gives me 16 pi over 45. And then we know our arc length is 10. We don't know r, but we know our angle in degrees is 16 pi over 45. Therefore, the radius is 10 over 16 pi over 45, with a radius of 8.9. It will be 5, 2, 3 significant figures, and that will be in centimetres. Then example number 3. Calculate the area of a sector if the radius is 12 centimetres and theta is 0.24 radians. Give your answer correct to significant figures. So this time we want to know the area of the sector. To do that, we're going to have to think about how we would do area of a sector in radians. So let's think about how we would find the area of a sector in degrees. Well, we take the area of the full circle, and again we multiply it by the fractional circle we have, which is pi over 360. Let's think about how that would work in radians. So it'd still be pi r squared, but it would now be theta over 2 pi. Let's again write that all as one fraction. So pi r squared theta over 2 pi. Let's figure out what's going to cancel out here. So the pi's would cancel out, leaving me with r squared theta over 2. So we now know the area of a sector, r squared theta over 2. We have the radius and we have the angle. So we know that's going to be 12 squared times by 2.4 over 2. That gives us a sector area of 172.8, and that will be centimetres squared. And it did ask for it to 3 significant figures, so that will be 173 centimetres squared. Question 4. This time we have a triangle and we have the sector, and then if we take the sector away from the triangle, we're left with this segment here. So we want to find what that would be. So we already know that the area of the sector is r squared theta over 2. Let's think about the area of the triangle, because if we take away the area of the triangle, If we take that triangle away from the sector, we're left with the segment, which is what we want. Remember the shaded bit, that is our segment. So the area of any triangle is a half AB sine C. So A and B are both R, and then C is theta. So it'll be a half R squared sine theta. So now the area of the segment, we just subtract those from each other. So R squared theta over 2 minus R squared sine theta over 2. So all I've done there is a half. I've just divided the whole thing by that 2 rather than leave it as a half, because that will make it nicer to clean up. So let's put everything that they share on the outside. So they both share an R squared and they both share a 2. And that leaves us with theta minus sine theta. And that will give us the area of a segment. So let's first of all find part A, the shaded area. It's going to be R squared over 2 theta minus sine theta. R is 10, it tells us that in the question, over 2. Theta is 2 pi over 3 minus sine 2 pi over 3. Now if you are working with your calculator, what you need to do is make sure it's in radian mode. So press shift, setup, and then if you go down to angle, make sure you're in radians when you do this. And that gets us 61.4, and we want it's the shaded area, so it'll be centimetres squared, and that will be again to 3 significant figures. And then we need to find the perimeter of that shaded area. So the perimeter will be the arc length plus this length here. Arc length we know how to do, it's finding this length here in our triangle, but we should be able to do that using the cosine rule. This will be side A, making that angle A, and then these two will be B and C. So A will be equal to the square root of 10 squared plus 10 squared, because they are both 10, because they are the radius, minus 2 times 10 times 10, which is 100, times by cos of A, which is 2 pi over 3. We then get that A is 10 root 3. So the arc length is just going to be R theta, with R being 10 and theta being 2 pi over 3. So that will just give us 20 pi over 3. And then it goes together. So the arc length being 20 pi over 3 plus R10 root 3. And that should give us the perimeter of the shaded area. That gives us 38.3, and it's a length, and that will be to 3 significant figures. Then example number 5. So a sector has an arc of 8 centimetres and an area of 36. Find the radius and the angle theta. So we know our arc length is R theta. R theta is equal to 8, and then the area, which is R squared theta over 2, that is equal to 36. So what I would do here is I might separate this out and say, well, it's R times by R theta over 2 is 36. And then I can replace the R theta with 8 there. So that then becomes 8R over 2 is 36. And then that becomes 8R is 72. We're going to go ahead and say that's 9. So I've got a radius of 9. So I can substitute that into my arc length, really, can't I? And so 9 theta is equal to 8. So therefore theta is 8 over 9. Now let's try that with our area calculation. So if we do 9 squared theta over 2 is 36, which would give me 9 squared theta is 72. So theta is 72 over 81, which I believe is the same thing as 8 over 9. So there we go.